Thank you so much, Tim and Biplav, for the invitation to participate in this. First off, of course, I hope that you can hear me okay. I will share my screen. So I'll start with that. And then I'll probably just, for bandwidth issues too, I'll probably just turn off my camera. Again, thank you, Tim and Biplav, for the invitation. I'm just sharing my screen. And I hope to keep this, not too long, just so that we have some time for discussion, as is the usual practice with these working group meetings. And of course, also, since I see a few additional faces that I think might be their first time visiting this working group, particularly my fellow Belizeans. I see people like Edgar, Sylvia, Andrew, Rubier, and anybody else who might be here from Belize. Welcome. And of course, this talk is also going to focus partly on Belize. So I guess to kick you off, just to say that this is not the very first time that I'm giving this talk. So last year, the Civil West Africa Machine Learning Working Group also had invited me to give a talk, and I gave a version of this. And so afterwards, when you have access to the slides, I have the link to the YouTube recording of the talk that I gave last year. But I will take a slightly different approach with it this time. And again, just really appreciative of the chance to finally jump on the soapbox for one of these talks. First off, just in terms of some background, I think a lot of people are familiar with the scikit-learn algorithm cheat sheet, which kind of gives you a perspective on the different things that are available out there. If you're just starting to get into geospatial, artificial intelligence, which is, again, the focus of this working group, meeting people where they are and the different phases that people are. This cheat sheet kind of gives you this, really cool idea of, depending on how much data that you have, what approaches that you can take, so classification approaches, which I think a lot of people are already familiar with, whether we're talking about supervised classification, unsupervised, also, regression-based approaches, etc. And then I'm going to take us back a little further into time. Myself, along with Tim, Biplav, Modu, who I see here, and others, Professor David Soff from the University of San Francisco, on the heels of Geo for Good, back in 2019, organized our severe global TensorFlow technical exchange. And for me, it was a really informative experience. And I'd just like to kind of jump from that to September last year. Dr. Mabai, who, again, Modu, who's on here with us, he gave this really great talk, kind of, 5 years later, showing, what he had done with, all that he had, the journey he had started, and the journey that other people started, again, in this TensorFlow exchange that we had back in September 2019. And I have to say that, I was able to participate in, see when Modu gave his presentation back in early September last year, almost a year ago. And I was, my mind was blown just in terms of how much, Modu had done with this. And of course, just to say, I know also that, Tim and Biplav and other people have really, gone to town, as we would say, in terms of the different resources that have been available. I guess you started off your journeys using TensorFlow and you've, gone further. And then just because, Edgar and others from Belize are here, a little less than a year ago, or actually, no, about a year ago, first week of August last year, we also had an in-person exchange. So you see Edgar there in the picture, along with others from the University of Belize and the Belize Forest Department, Land Information Center, where we were looking at land cover change and land cover mapping. And I'd like to say that I guess we kind of did it old school, where we were using supervised classification approaches, random forest, etc. And as Edgar or anybody else who participated in this exchange, Betsy, etc., from our office, they would also tell you we definitely ran into technical challenges of, we were able to, I guess, do a decent classification. And then since then, Edgar and colleagues led a really stellar effort getting field data, editing this data even further, et cetera. But it's kind of, I think we ran into a wall in terms of what was possible just using a supervised approach, which then again, when I saw a few weeks later, Modu's presentation showing all the great stuff that he's been doing with deep learning, and of course, having worked with Tim and Biplav and seeing the stuff that they've worked on and has also been highlighted in these types of meetings, the Geo-AI working group, I felt a little left behind in the sense of, I had not, I guess, kept my technical chops up in terms of this deep learning stuff. And so just, those of you who know me know I'm a big fan of memes. I also like music. And so back in 1993, the Cranberries came out with their album, everybody else is doing it, so why can't we? And then I was like, I had a different version of this album cover where I scratched off the it, wrote in deep learning. And yesterday I went to Gemini, I said, give me a cartoonized version of this thing. It's like, well, if everybody else is doing deep learning, why can't we? And so that's kind of my approach to it, or coming from, again, this exchange that we had with Edgar and others. It's kind of like, all right, if we've been able to go only so far using supervised approaches, could the solution be, could it be that, okay, we have to go down the deep learning rabbit hole? And so one more meme, and then I'll get into the meat of what I'm presenting. And it's kind of, the way I saw it is, if the issue was that we're not applying deep learning, then the solution is we need to apply deep learning. But for a lot of people, the issue is how. A lot of people, including myself. And so just to give you a quick outline of what I'll be talking through, and again, I'll try not to extend it too much. I just wanted to talk to you a little bit about how one way of jumping into deep learning would be using the different tools that are out there available through ArcGIS Pro. And why ArcGIS Pro? Of course, I'll get into that a bit, but in terms of meeting people where they are, a lot of people around the world are, desktop GIS people. So either people who use ArcGIS or people who use QGIS. And so that's, one way of getting into things. And so just in terms of, some brief objectives for some of the things I want to show, I want to explain to folks, how you could execute deep learning-based land cover classification using ArcGIS Pro 3.x. Also look a little bit at some of the challenges that you might have doing that. Also start to get into some of the best practices. And then I should also say, though, that in talking with Tim and others about this sort of work that I started last year, he also indicated that in one of their AGU sessions, the AGU conference sessions, I think back in 2022 or so, Tim and Biplav also had a really great talk on deep learning approaches in using ArcGIS in their session. So it's obvious that for the last few years or so that this software has been around, the deep learning part of ArcGIS Pro, that people have been doing stuff with it. So I just want to, I guess, share my experience with that. So ArcGIS Pro, if you want to start diving down the rabbit hole, you're going to need ArcGIS Pro. And then apart from ArcGIS Pro, Esri has provided these libraries or installers that connect to PyTorch, connect to TensorFlow, and you can grab those off of a GitHub page. And so that's fairly simple. And then also to say that they do provide detailed instructions as well as to how to install those packages, which for the most part, it's just, you have ArcGIS Pro already installed, and you have it installed, and then there's this additional package that you'll need to install, for instance, if you're using Windows, because we all know that ArcGIS Pro runs on Windows. In terms of how long the process is or what that process involves, and I guess this is a little bit different from some of the workflows that people who've been using, TensorFlow, using Colab, et cetera, what that might look like. So, collecting your training data, which could take a few hours, depending. Exporting your training data, which is a fairly fast process. Training your model, which, depending on what kind of computational resources you have, if you have a machine with a GPU or without a GPU, the difference can be hours. And then doing the inferencing or the classification, as we old school people like to think of that might take, 30 minutes or an hour, depending on how heavy your data are. And of course, I'm gonna get a little bit into the vagaries of, again, when I say it might take this long or that long, kind of why. And the examples that I'm gonna share here, I'm gonna talk a little bit about Belize, the country of Belize, and why, because it's a fairly small country relative to the work that some of the other folks do. We have Kung San Un from ADPC, and they're talking about, Southeast Asia and the Mekong region, which is, million square kilometers or something immensely huge. And here I'm talking about a country that's, less than 100,000 square kilometers, and so fairly easy to do runs for. And then building off of, I already mentioned before that with Edgar and Betsy and others, we had this exchange last year. We worked a lot with a Landsat image mosaic, a Landsat 9 mosaic from 2023. I used that same mosaic as the input to this process I'm going to show you. And then one, I guess, way of cheating or speeding up the process that Tim, Biplav, Modu, and others will always tell you, sometimes maybe you want to resample your data to something more manageable to speed up the process. And then after you've worked that out, then you try it on the original resolution data. And just to say, of course, with what I'm going to share here, everybody's always free to try this on their own area of interest. The other thing to mention is, so this is a screenshot from ArcGIS Pro. In order to get the deep learning tools to work, you will need a license for image analyst, which is, I guess, not standard with ArcGIS. It's an additional license. However, one thing to point out is if you request a trial license of ArcGIS Pro, which only lasts for 21 days, it does include spatial analyst, image analyst, et cetera, et cetera. So just to say that it's not, completely unattainable. It's something that, if you work for a university like, Tim, Betsy, myself do, university licenses, I believe, generally include image analyst. And if not, again, there are other ways to get access to that. One of the things that I guess I came into when I, decided, look, let me see how this all works is, you obviously have multiple options there. And then afterwards, and just following up, because we also had an interesting training yesterday, leveraging foundational models, Prithvi, using Colab, et cetera. And one of the kind of lessons from the training that we had yesterday was, obviously, you also have to, for people who haven't done this before, or for people, it's always useful to give people steps of, okay, here's the first step, and the second step, and the third step. Not a criticism, but the way that the deep learning tools in ArcGIS are set out, it might not be completely intuitive as to how to start off. But so just to say, first we're going to export our training data, then we're going to train our model, and then we're going to do the classification. And in addition to that, as I'll show in a wee bit, they also provide other tools for evaluating the outputs that you're going to generate. And again, where am I coming from? Just to say it again, coming from the perspective of somebody who, I do have background in, I guess, classical machine learning, et cetera. But a year ago, deep learning was, even though I went to the deep learning exchange with Tim Biplav, Modu, and others, I hadn't gone down that rabbit hole. And for me, ArcGIS was the vehicle by which I was able to start going down the rabbit hole. So step one, exporting training data. Give an example. Here are some of the same training data that we had used for the exchange with Edgar, Betsy, and the other colleagues. So again, you start here. You're going to need, polygon or shapefile of training data. And then, of course, not just that training data, you're going to also have to give it a raster data set that you're going to, essentially clip the data to. And so in this case, again, as I mentioned before, I decided to try to speed up the process or to see how it's going to work. Took my Landsat mosaic, which was originally at 30 meters. We sampled out to 100 meters. And also in this case, I also did the other process of standardizing this data, going from the original 0 to 10,000 values to rescaling it rather to 0 to 1 values. If you want to know why, any of the other colleagues from the working group can tell you kind of why we need to do that rescaling or standardization. And of course, specifying an output folder and the shapefile as mentioned there before. And then on the other slide, yeah. And so then one of the things too with the training data that we're going to use in this kind of process, it will need a field that differentiates between the different classes. So you can't just, okay, I have these samples, but you need to also have the samples saying, well, this is forest, this is water, this might be an urban area, that kind of thing, so that, when you're doing your training, it's saying, all right, you can then separate these things out. The other part that's super important to this process, and again, others who've been further along the journey can explain to you why, but the patch size that we're going to be using is also something that's important to consider, and we'll get to that in a wee bit. The other thing, I guess I do document a few kind of issues that I ran into when I started using this, is by default, well, let's just say by default, ArcGIS will pick a metadata format called Pascal Visual Object Classes. However, to then actually do a classification, you do need to switch that to something else. And Esri, under their tech support pages, does have well, if you try to do a classification and you use that default Pascal Visual Objects thing, it will not allow you to classify. And so the simple fix is under that metadata option, you need to pick classified tiles. And so again, as you see here, you have multiple options of what kind, what type of data you're inputting. You just pick classified tiles. And then the other issue that you're going to run into, as shown before, by default, Esri picks a default of a patch size of 256 by 256 pixels. I know in other work, people have default patch sizes of 224 by 224. And I just wanted to show, or actually maybe I'll show it slightly later. Depending on the pixel size of your data, this can be an issue. But let me continue. So initially, when I started this stuff off, and again, kind of coming into a little green, I just went with the, again, my data were 100 meter by 100 meter, and I was going with 256 by 256. Actually, no, I'm remembering wrong. When I did my first test, I said, I want to run this pretty quickly. So I even went with 500 meter data. And if you do the simple math of multiplying 256 times 500 meters, or half a kilometer, then we're going to end up with patch sizes which are 128 kilometers by 128 kilometers. And essentially these patches, at least in my experience of using this tool, the patches should be fairly homogeneous, should be the same thing. But as you can see here, if I'm taking a patch that's 128 kilometers by 128 kilometers, and I'm saying this is all one thing, really, based on the size of my image, I'm getting more than just one thing. So it's not just forest. I'm getting agriculture. I'm getting savanna, grassland, water, urban areas, et cetera, et cetera. And so what I learned from painful process of trial and error is that depending again on the size that I was using, I then needed to tweak this tile size a bit. And I've also had, follow-up conversations with Tim and others talking about, well, yeah, but if you make the tile size too small, and when you're doing these convolutions that are a part of the training process, it might get kind of funky with how it extracts that signal. Nonetheless, I did go with this 10 by 10 patch size instead. And I was able to get, well, as you will see shortly, I was able to get results that weren't too bad. And so a 10 pixel by 10 pixel patch size at 100 meters, et cetera, you do see that for the most part, this is homogeneous now, or more homogeneous than what we could see before. And so you've got these options, you hit that export button, you hit that run button rather, and then you see that in this case, again, from over a year ago, the exporting of the training data only took a whole minute, which is not too much. So then you can then move on after you successfully exported your data in the form of patches, et cetera. You can now move on to training the model, and you don't need me to tell you, but training models usually it's the part of the process that takes a long time. But how much time it takes will again depend on the data that you're using, the spatial resolutions, et cetera, et cetera. And so, what does the trained deep learning model part look like in ArcGIS? At the get-go or at the outset, it looks fairly simple. And so in this case, I input the training data set that I had exported. I give it a folder. I have to pick how many epochs that it's going to do the training through. And of course, I don't know if Tim or Biplav, because you've given better explanations than I have in the past of how the epochs work, of say passing the data through and passing it back, forward and back, forward and back. I don't know. Tim, Biplav, anybody want to explain just for the group how the epochs work?
It's your total number of times that you're looking at that data. So you could have like a batch number that's like how much data is given to the model, like say it's a little pot of data, and then the epoch is how many times it runs through your whole data set, essentially. So you could look at those two factors as how much information you provide to the model over time.
Awesome. Thanks, Tim. And then by default, I believe that Esri's default is that they, say do it for 20 epochs, but they also do recommend that you test. And one of the things that you will find is, generally speaking, if you increase the number of epochs, you will increase the accuracy. But the more time that you spend training, then the more time it's going to take as well. And in addition to that, so then this is just, again, how this looks. Of course, you get to pick a model type, and I guess I'll get to that in a moment. But there's also this option that isn't, I guess, stretched out as when you start up the tool under advanced, but definitely recommend that that's one of the things you want to do. But in addition to that, Esri's trained deep learning model tool does give a number of model types that you can choose. And I think, I'm trying to see if in my next slide, if I kind of show what those are, but I know that UNets are, ones that people in this working group have used quite a bit. And it also gives you you also have to pick, well, by default, it goes with the ResNet 18 backbone model, but you also have a number of other backbone models that you can select as well. Okay, so in this one here, just kind of showing what the different options are. There's UNet, there's DeepLab version 3. You can also use segment anything as the model type you're going to use. Backbone models, there's a lot of them that you have to choose from. And when I just started off, I was like, all right, let's just go with ResNet 18 because it's fairly simple. But of course, there are ones that I guess use even fewer hidden layers like VGG 11, etc. But just to say, you have multiple options that you can choose. And of course, if you're just getting into this stuff, my recommendation would be, why don't you try out different backbone models and see if ones with more hidden layers, more layers. So the ResNet 152 has 152 layers compared to the 18 of ResNet 18. Test those out. Of course, you will find if you pick ones with more layers, then it's going to take more time, etc. But trial and error being one thing. And just to also say, one of the things I do appreciate is Esri does give a bit of background in terms of the different backbone models that they provide, what that looks like. And I know that this working group, on the page for this working group, there is other documentation that kind of shows you what the architectures for like a ResNet looks like versus some of these other ones. So yeah. And so let's say you pick the default 20 epochs, etc. I was able to, with the data that I had, I was able to run this stuff in an hour, which some of you might say, that's a lot of time. However, just to also say though that the time that it's taken, I've also found to be variable depending on the backbone model that I'm using, et cetera. And so again, this ResNet 18 with 20 epochs took an hour. ResNet 18 now, same data set with 50 epochs, doubled more than, well, barely, doubled the time, et cetera. ResNet 34, now with 50 epochs for whatever reason, only took an hour. However, I guess one of the other things that I should point out is usually when you specify the maximum epochs, there's also an option of running this where it says here, stop when the model stops improving. It will not necessarily run it for the 50 epochs. So if after 18 epochs, it can't basically improve the model anymore, it'll stop there. And so likely in this case of the ResNet 34, it didn't go the full 50, and so it stopped earlier, which is why it only took this much time. And of course, just to say, this is all running on the desktop, and the cool things that we've seen in the past from Ate and Tim and Biplav and Modu and Alan, Mwangu and other people, you've done stuff, using cloud-based resources that generally run quicker than 3 hours or what have you. So the other example here, just to show, instead of using a UNet, I used Deep Lab instead, and then this one took even more time than the other ones. This one here, using a different backbone model, MobileNet version 2, took now like 5 hours. But again, I guess the overall like lesson from all of this is it'll depend on the GPU that you have on your laptop or on your desktop. It'll depend on how big your the training data that you've generated are, et cetera, et cetera. But just to say, if you're just getting into this, it's a neat way, I guess, of doing trial and error. And then lastly, or start to wrap up on this part, the other part, after having trained your model, you now inference the model or you do your classification. And so, what does that look like? A window where you now give it back the original input image, tell it what your output, in this case, a land cover map is supposed to look like, and the definition of the model that you're using. You can also tweak the parameters provided there. And you'll see that the inferencing or the classification generally runs quicker than the model training. In this case, took 30 minutes. And then one of the other things, as I start to wrap up this talk, one of the other things that I thought was cool about ArcGIS Pro, and maybe this can also be done with the different notebooks that are out there. But I really liked that ArcGIS Pro did provide tools that help you to understand the performance of your models. And so under deep learning tools, that option, again, if you have the image analyst enabled to be able to do all this stuff, under imagery, you're going to see something that says deep learning tools. I should say that this is I think this is from ArcGIS Pro 3.3, then now up to 3.5. And so the window looks slightly different. Now it has like three different options, but there's an option there to review your deep learning models. And when you do that, you can basically pull the model that you've generated and then start to look at, the training and the validation loss, how many batches were processed, and the different accuracies that the model starts with and the accuracies that it finishes with, this dice percentage, et cetera, et cetera. So in this case, one of the first models I was able to run, the starting accuracy was something like 68.6%, and it ended up with, having passed through multiple epochs, finished at, almost 75% accuracy. And you see in this case, if we said, maximum 20 epochs, it took all 20. And in other cases, in this other one, I said, let's run up to 50 epochs, and it stopped at 38. And the final accuracy was 74.5. And actually, for this other one, the previous one I was showing, also stopped at 74.5 and only 20 epochs, versus this one where it took 38 epochs and still only got to 74.5. And then now, in these two previous examples, we're looking at ResNet 18 as the backbone model, now using ResNet 34, which is again a different architecture. We see that the final accuracy is even lower. And let's see. We have a question from Sylvia in the chat. Ability to do computational configurations or different cores for covering large areas. Let me ruminate on that question just a little bit. But yeah, with this one, I just wanted to, highlight that using different backbone models that have different architectures, you will end up with, and again, I'm using the same training data, same input imagery, but came out with different looking results, different accuracies. Now using Deep Lab instead of ResNet, different accuracies. But then I'm just going to jump forward and say one of the other ways, of course, of reviewing the model outputs, which I guess everybody does, is after you've generated your output, you say, let me look at this. And then again, we have people like, Edgar and Sylvia, Pierre, other people who know what land cover and beliefs should look like. The first thing you eyeball it, it's like, all right, does this look believable? And so here's, based on ResNet 18 on 20 epoch, and we say, all right, looks fairly believable. But of course, in this case, I always, for the red, I'm putting as urban areas. And so people from Belize might say, you know what, Emil, the forest came out kind of all right, but it's got too much red because like in Spanish Lookout, that's not all urban areas. This isn't all urban areas. And then somebody like Edgar might also say like, well, and also you're missing some of the secondary forest in the Toledo district, but say overall this doesn't look too bad. Here's based on same resident 18, but 50 epochs. And you notice now instead of, well, so the yellow is agricultural areas. You notice now we've kind of cleaned up, as it were, some of the urban areas that were there, but now it's saying that these areas that are probably farmland, it's like sugarcane. Now it's saying it's savanna. That's what I have for pink. And it also still didn't resolve that issue of all the farms in the south or the secondary forest. So now that was resident 18, 50 epoch, but now resident 34, 50 epochs. I say, all right, maybe this result looks a little bit better than the two previous results. Maybe it has fewer urban areas or something. But again, like this is one way of evaluating. And of course, as shown before, when you run the model itself, it tells you in theory what the accuracies are. But of course, we're not testing these against ground truth data that the type that Edgar and others have access to. However, now going from UNets to Deep Lab, instead of a UNet, using Deep Lab, however, using resident 18 and 50 epochs, we see that this output is just saying like, half of Belize is just urban areas. And for those of you who are familiar with the area, know that that's unlikely to be the case. And I promise you, I'm starting to wrap up. What else to mention? So now, like, all right, if we go back to using UNet, but we use MobileNet as the MobileNet version 2 as a backbone model, we see that this result, okay, maybe actually looks better than many of the other ones, because we see fewer red. Again, we see this issue of in the south that it's not quite classifying what we want it to. However, going from MobileNet version 2 to MobileNet version 3, same data, just now, different backbone model, same number of epochs. We see that the country is completely forested, which I guess, is great, except it's not true. And so that all said, I guess I leave it to, the people from there who were doing work in this, people who are about to start PhD programs or have already started. It's up to you folks to kind of dig into this further. But one of the things that I did do, Tim and others are aware, I've been keeping this huge Google Sheets spreadsheet of, like, I do all these model runs. I even document which computers I'm using them on, if the computers, are computers that have GPUs or not, how quickly they're able to do the processes. And I guess one of the things to point out compared to like a year ago, the computers I'm using recently that do have GPUs are able to do trainings in like a few minutes versus like in the beginning where it was like taking a whole hour, etc. And I'm even, just documenting just for the process of documenting it, how large the models are that they do generate. And then I do have another process where when I do inference and export these land cover maps and say, all right, I just have some questions like, all right, the Belize City, which is this characteristic area, does it look well defined? Yes, no. Do these areas in the south of Belize, which should be coded as secondary forest, does it pick it up as secondary forest? Yes, no. Does it have too many urban areas versus other things? Yes, no, or somewhat, et cetera. And so just to say, I've been documenting these, and Betsy and others know that my pipe dream is to take these almost 200 runs I've done and somehow write it up in a paper. But I guess it remains to be seen. In case y'all want to check out the table, you can scan that link there. The table's open. And then lastly, almost lastly, and promise, just so we have some time for discussion. One of the other things, just to point out, earlier when I said, well, what if we kept those the original default parameters of tile sizes or back sizes of 256 by 256 pixels, and we run it, what would that look like? Just one interesting thing of like running it. According to the model evaluation, it's saying like, wow, I had like a 99.9% accuracy, which obviously, the way I read 99% accuracy means my output should look perfect, right? except when I did the classification, this is what it looked like. And I guess what we can see is my training areas, it looks like the training areas might have classified correctly, but the non-training areas really didn't classify correctly. So I guess one other interpretation I had was that the model was likely really, really, really overfitting. But again, I'll finish up and we'll have a few minutes for discussion. I'd also be interested in other people's thoughts on that. In conclusion, what did I at least learn from this entire process is that deep learning doesn't have to be unattainable. It doesn't have to be something that's like, if you're somebody who's more used to doing GIS and spatial processing using a GUI, you can do deep learning using a GUI with ArcGIS. And in addition to that, just to say, well, as said before, ArcGIS, you will have to install these additional libraries, which, it's not a hard thing. You will obviously have to appropriately pick your input imagery and training data, appropriately pick your parameters. You can do it in 3 steps. If you pick the default parameters, you're likely not going to get an output that you want. It could take a long time if you don't have access to sufficient computing resources, i.e. a GPU. But ArcGIS Pro does provide tools for looking at your model outputs and model performance. And in terms of future work, though, I guess I'd like to think of this as a gateway tool for hey, maybe you say, you know what, I'm going to ease into deep learning work, GUI-based, using ArcGIS Pro, and then after that, I can branch out to more complicated things like you've seen from other presenters to the working group, like using TensorFlow and Vertex AI with Earth Engine via Colab, or there are also options using QGIS. And I guess lastly, you obviously have all the resources of the Geo-AI working group on their website. There are also other webinars and MOOCs that you can subscribe to, like NASA RSET did this really great webinar back in 2023. EU College from funded, I guess, supported by ESA, also did a neat MOOC last year. These are available to anybody. There are also some really awesome deep learning related resources from Google Team. The 2022 one that I'm citing is from Geo for Good 2022. But in any of the Geo for Goods, including what Biplav mentioned before, in each of these, they are always highlighting the latest and the greatest of deep learning, including the foundational model stuff that was mentioned before. Just like to quickly plug the applied, and I know it's not the current cover, but the applied AI and deep learning book that Biplav and Tim and David are editing. And so that's coming out. There's also I believe a GitHub page for that you can, I guess, check out certain updates on, and of course they can speak more to that. Also, I'd like to say though that when I started getting into this, one of the things that I started doing was I created initially a Google Doc of putting together different links to resources for the classical machine learning or the deep learning things that I was finding, uncertainty assessment, or where I could find installers for things. I recently converted this to a GitHub page, which you can find there, or if you find me on GitHub, it's one of the repos that's there. And I'll close off just by acknowledging the great work that colleagues like Tim and Biplav have been doing by shepherding this working group since 2019 when the working group came into being. Also, great tips and tricks I've learned along the way from folks like Kel and Nick from the Google side, David from University of San Francisco and SIG, Modu, again, this awesome presentation that you gave last year that really inspired me, Ujjwal from Spatial Thoughts, Glory from AfroGIS, who invited me to give the early version of this talk last year, Betsy, Edgar, Sylvia, and others, and then colleagues as well from Esri, who also helped provide some troubleshooting tips. If you have any questions, you know where to find me on email. I think this is to my GitHub page, and I will stop presenting and just say thank you for this opportunity to chat with y'all and for your time.
Amazing.
Thank you,
Emil. As always, fantastic presentation. Blown away. I'm going to open up to questions. I just wanted to give a couple comments right off the bat. Thank you for giving a full end-to-end walkthrough. As you've been a part of this group for 6 years now. we primarily used to do that. It was like, here's your method, explain how you did everything, all the choices you made. And I love to see that again, because we get so caught up sometimes doing presentations on like the next wave of things and more theoretical and maybe a little bit of demo, but it's great to see like really nuts and bolts of all the choices that you made and working with packages and things like that. It's fantastic. And also massive kudos to all the record keeping that you do. Those model runs, we all know, it's like it could be you run something and then disappears, but you're actually tracking like all of these past efforts. So you can really start to hone in on like the performance and the approach overall. So I'm hopeful that like through all this effort, you'll get some ground truth data and then maybe even publish a paper on this, because like you've done 200 models. It's awesome. So thrilled. And I'll open it up to questions if anybody's got any.
Sure, but if I could just quickly say too,
yeah.
One of the reasons too of like documenting and putting in a table like what worked and what was the accuracy, et cetera, is like just because too like all the time that it takes to do one of these runs, where in some cases it might take like an hour or so. I also don't want to repeat the run. So by like knowing where it is, et cetera, and obviously I'm saving the outputs as well, but by doing it that way, then I know I've spoken to you and Biplav like at Geographic last year. And then, Biplav was like, well, did you try the bit B option or something? And it's like, all right, let me try that, and, ran into certain issues or whatever. But it's also just been helpful to then think through that process. But also just to say, I've learned quite a lot from attending these virtual meetings and, being blown away by the presentations I've seen from other folks. So, yeah.
Yeah, I love that in Arc, they have like VGG options and UNet options and MobileNet. Like I feel as though like that package that you were exploring really does bring in what was the state of the art, or was like the cutting edge, now state of the art, into like a series of options that you could just start exploring right off the bat. And I feel like the barrier to entry is like significantly less, because now you don't have to, you can download those models and use them in a collab, but you can then just sort through all these different models, and it's very, very easy to sort of just move through them. So I think that's a great way to sort of get people into deep learning. And I know that's like the main thrust of this whole working group in some ways, is to meet people where they're at. So I'm really excited by this talk, because it really demonstrates all the ways in which you can start exploring these different models for your use cases. So yeah, kudos. Any questions on the line? I know I saw some comments about folks interested in maybe the overfitting. I really loved how you presented even the results with your training patches, right? Like that's a nuanced thing of getting locations that are really specific to the model you're looking at. I think you predicted water for like, it's like all ocean or whatever. I think your blue might have been.
Yeah, and I know Sylvia had a question in the chat.
Oh yeah.
Or I see also Rubier, or maybe Rubier partly answered it or fully answered it. I don't know if Rubier or Sylvia or Edgar, anybody wants to come on, Mike.
Hey, thanks, Emil. Edgar here, and good to see everyone around as well. And really interesting stuff, and indeed, something for me to explore as well from our side, and see if something that how it compare maybe what we've done in last year's work, and some of the extensive post editing that has been done over the last few months by the team here, and see what how that compares. At the end of the day, what we want to do is something more practical and efficient, as these images are coming out and everything are moving forward. So definitely something to look at back in terms of what's happening as well. I'm guilty of not being up to date with some of these things that are coming out, but now I foresee to see using some of these things much more. So thank you, Emil, for that presentation, and thank you for always using Belize as a case study.
And thank you, Edgar, also for providing the data and the opportunity. And just to say also, congrats to Edgar, who Little Bird tells me will be pursuing PhD studies very shortly, and hopefully will be integrating deep learning into his PhD studies. And I think Sylvia, you had a question, comment? Please jump in.
Yeah. Thank you very much for this presentation. This was very informative, and I will definitely be using it in my research. Um, Basically, I will be focusing on coastal areas and islands. So hopefully, I'm able to utilize some of the deep learning models in those areas. It has basically given me some insights as what I can do with my community data that I have collected via sketch mappers and see how we can go from there. So this was very insightful. I appreciate the different results and understanding it's okay to try different things to see different results because it's all about trial and error. So, and I'm really happy to know that it will be possible in these regions. So it's just basically moving forward from here. And thank you very much for the presentation.
Yeah, thank you for participating, Sylvia. And then I guess for folks who might not be aware, Sylvia is doing her PhD not too far from where we are. She's at Auburn. She's in the lab of Tim Hawthorne.
Thank you.
I was just going to make a comment that, if there's any questions on all the great stuff that Emil presented on like those different model architectures as well, I think that our group had spent a huge amount of time just in only discussing the models and maybe some space talking about training data preparation, which is in itself is its own thing, like a massive effort, right? So if you guys have questions, and I know you're joining this working group sort of newer, but like there's a bunch of institutional knowledge in this group. I know like Ate, I think is on the line. He spent a lot of time like getting MobileNet to work for a particular use case, like the nuances of that model. So one shines bright as in your trials, like reach back out to this group on any kind of questions you might have.
Andrew from the Ministry of Agriculture as well. I mean, he's actually looking at something like this. I hope it's insightful for you, Andrew, in terms of using some planet imagery and seeing as well in terms of deep learning through ArcGIS Pro. So hopefully that's something of use today, Andrew.
Yeah, morning. This was a very interesting presentation, and I have been trying to test more deep learning models with ArcGIS. Or currently I'm using QGIS because since we don't have the image analyst tool, but hopefully that's something we can convince our ministry to obtain later down the line. But thank you for the presentation. This is very insightful.
Yeah, and I guess, Andrew, just quickly too, like I said, if you can get the 21-day trial license, which I guess will only be useful for 3 weeks or whatever. I wonder though if you were to, well, I guess you're probably already in touch with Ms. Loretta at TBSL about those things, or I know in the past too, Edgar has advocated for and gotten cooperation with Forest Department and the University of Belize, where they do have access to licenses for these things. So I wonder if that might be a collaboration that you guys might also be able to explore. No, I know that Professor Kano over at UB has been really supportive of this work.
Yeah, we can try to explore that.
Yeah, I think we still have access to with some of the licenses from University of Belize, Andrew, from the land cover classification that we were doing. So definitely could speak to Kano and see how you can get one of those users include as part of your research you're doing.
That would be appreciated. Thank you.
If I could just also mention one other thing too, just in follow up to what Tim was pointing out. So Biplav has maintained the video listing of the previous presentations that this working group has had since 2020 or so. And I believe that the link to that is in the notes that Tim shared there in the chat. So again, for people who are fairly new to this working group or whatever, like please also feel free to check out the webpage, check out the notes that are there, but definitely also check out the recordings from other people who've been who've given some really awesome presentations. I don't want to like single out anybody specifically, but again, I know that Modu's one last year was just blew my mind in terms of their incorporation of like drones into agricultural mapping, etc. I know Modu, you're on I don't know if you wanted to say something. I guess Motive might have mic issues because I see him in the chat, but again, awesome stuff. And again, I really appreciate Tim and Biplav for keeping track of like all the previous presentations, which have so much knowledge and wisdom to share. I guess back to you, Tim.
Yeah, thanks so much, Emil. I just dropped in the YouTube link, and I think there's a playlist in there for Geo-AI in particular. Biplav, I see your hand up. Go ahead.
Yeah, I don't have any question, but I just want to say thanks, Emil. Great presentation. It's wonderful you have like all those spreadsheet maintained.
Yeah.
It's courageous. I try to do that, but it just gets out of hand. Yeah, and I'm also like my first intro to GIS was ArcGIS, like playing with it, and I'm really happy to see that they have met where the problem is, like where the users are, and without having to learn all the extra steps. And thanks again for your presentation on walking us through all the steps. I haven't used it personally, but it looks interesting and might want to try. And I think ArcGIS you can also run in Azure, so you could also use some of the cloud services, like you have access to greater GPUs and all those things.
Biplav, can I ask a quick follow-up question? I know that at Geo for Good last year, you also presented on the work that Wilpert has been doing, I guess, with ArcGIS and stuff. Is there anything on that side that you might also want to share?
Yeah, sure. So Earth Engine this year, they've been focusing a lot on connectors. ArcGIS connector is one of them. There's also QGIS connector if you're a QGIS user. But it basically helps you bring in Earth Engine data sets. You could integrate those in the ArcGIS model builder and build your model using the data sets from there. So it's a really good way to also use some of the functionalities that Earth Engine provides, which could be great for integrating ArcGIS as well as Earth Engine.
Well, wonderful. Yeah, again, huge thanks, Emil. You're welcome back anytime for any presentation. Always love your stuff. And I just want to say thanks, everybody. In 2 weeks, I think we'll have another lecture. I think we'll have an opportunity to talk with one of our ASTs through the NASA Severe program. So we'll talk in 2 weeks. Thanks, everybody.
Thanks, everyone. We'll see you in 2 weeks.